So today I want to work on some multi-step conversions in stoichiometry. So each time you're doing one of these problems, the first thing you need to do is to balance your equation. So if we look at this reaction here, we could start with the oxygen. So I'm just going to start by putting a 2 here on the reactant side to make that 4 oxygens, to make that number larger. To then balance out the oxygen, I would need to have a 2 here. And then if we look at titanium, to balance out the titanium, I would need a 2 here. And then that would give me 8 chlorines. To balance out the chlorine, I would need a 4 here to balance that out. And then I have 3 carbons here. To balance out the carbons, I would need a 3 here to balance out the carbon. So let's just double check. So we have 2 titaniums. We have on both sides, we have 4 oxygens here. 2 plus 2 gives us 4 here. We have 8 chlorines here. 2 times 4 is 8. 3 carbons here. 1 plus 2 is 3. So we see it's balanced. So when you're doing this, first make sure you balance the equation. And then we could write underneath that what we've been given. So here we have 4.55 moles of carbon, and we're asked for what mass of titanium 4 oxide that we need to do that. So I'm going to just write here. So we have 4.55 moles, and we're asked for the mass of titanium 2 oxide, so it's asking about this, the grams of that. Okay, so remember, this is going to be your A. So carbon here is your A, that's our known. And then titanium 4 oxide is our B. So here we're starting with, I'm going to imagine mass over here. We're going from mass of A to moles of A. And then we're going to, we're going from, misread that, we're going from moles of A to moles of B. And then we're going to go to mass of B. So remember, when we're going from moles of A to moles of B, we're going to use our mole ratio. And then going from moles of B to mass of B, we're going to use our molar mass. And since we're going away from moles, remember we multiply by molar mass. Okay, so if you're using the island, this will kind of help you to map out a roadmap of what you need to do. Okay, so we're starting with moles of carbon. And make sure as you're doing this, you're writing down now not only the unit, but like I said last class, also the compound or element. We're looking for titanium 4 oxide. So we're looking for grams of TiO2. Now you notice here we have 2 lines in our island that we're having to go through. So this means we're going to have 2 conversion factors. Our first conversion factor, as we can see here, is going to be the mole ratio. And we can also look at, we have moles of carbon. We would have to have moles of carbon on the denominator. And we're trying to go to titanium 4 oxide, so we'd have moles of titanium 4 oxide in the numerator. So if we look at our balanced equation, we can see that with carbon, there's a 3. So we're going to put a 3 here. And if we look at in our balanced equation with titanium 4 oxide, we have a 2. So our numbers are coming from this balanced equation. So they're coming from this and this. Okay, so now we have moles of titanium 2 oxide. titanium 4 oxide. If we look at it, we've gone from moles of A to moles of B. We notice here the moles cancel out, carbon cancels out, and now we're left, like I said, with titanium 4 oxide. Okay, so our next conversion factor, the denominator should match up with what we have here. So we're going to put moles of titanium 4 oxide in the denominator. The only place where you should see a number other than 1 with your with moles is in your mole ratio. So here this will have a 1. So this is our mole ratio, and this is our molar mass. Okay, so now we're going to have to calculate the molar mass of titanium 4 oxide and plug that in. So I'm getting my periodic table out, my calculator out, so I can do that. So we have oxygen, 16 times 2, and then I'm looking for titanium, and that's 47.88. So I have a molar mass of 79.88 grams, and that's of titanium 2 oxide. Now we notice here that the moles cancel out once again, and now titanium 4 oxide also cancels out, and we're left with grams. So now if we plug that into your calculator, we're going to go 4.55 times 2 times 79.88, and then divide that by 3. When we do that, I'm getting 242 grams of titanium 4 oxide. You notice I rounded that to 3 significant figures, and that is because 4.55 also has 3 significant figures. So this is a moles to mass problem. So we're adding on another conversion factor here. Okay, so let's